And this is a 2001 AIME 1 problem number 1. Here's a view of this problem. Find the sum of all positive two-digit integers that are divisible by each of their digits. So two-digit integers mean we can express them as n equals 10a plus b, where we have 1 is less than a, which is less than or equal to 9, and then we have 0 is less than or equal to b, is less than or equal to 9. Great. Okay, now what we want to do is we want to find the condition under which they're divisible by each of their digits. So that implies that 10a plus b over a and 10a plus b over b are integral positive integers, I may add. Great. So now let's consider each of these. So for 10a plus b over a, this is going to be equal to 10 plus b over a. And for this to be integral, that implies that a divides b. For 10, for 10a plus b over b, this is equal to 10a, 10a over b plus 1, from which this implies that b divides 10a. Alright, so now we can combine these two, right? So a divides b implies that b equals ak, where k is a positive integer. Alright, so now we can plug in ak over here. So we get ak divides 10a. And since a is non-zero, because then it would not be a two-digit number, we have that k divides 10. So k divides 10. So now it's just casework, because all we have are a couple of values that divide 10. So for k equals 1, we have that b equals a by this. So b equals a, so that means we have numbers 11, 22, all the way until 99. For k equals 2, we have b equals 2a. So we have b equals 2a. So we have like a equals 1, b equals 2, a equals 2, b equals 4, a equals 3, b equals 6, a equals 4, b equals 8. And then we don't go further since we know that b must be less than or equal to 9, like over here. So next is going to be k equals 5. K equals 5, that means b is equal to 5a. When a equals 1, b is 5. And then when a equals 2, b is 10, which is too big. And then by similar reasoning, if k equals 10, then b is equal to 10a, and then that'll be too big for a equals 1. So now all we have to do is add these numbers and we're done. So for this one, plenty of ways to add them. I'm going to do like 11 factor 1 plus 2 all the way until plus 9, which is equal to, oh boy, so 11 times 9 times, 9 times 10 over 2, which is equal to 11 times 45. And then for this guy, we have 12 times 1 plus all the way to plus 4. My pen's bugging out a little. So 1 plus 4 is 4 times 5 over 2, which is 10. So that's 12 times 10. So we want to add up 45 times 11 is 495. 12 times 10 is 120, and then we need to add 15. Adding so gives 0, 1, 13, 1, 6, 630, and we are done.